Welcome to my Texas workshop. I'm Randy Lammers.
I'm Aaron Keevan.
This is worth knowing. Would you like to apply accurate and even loads with a single pass on flange assemblies? Let's learn about a unique product called DuraSquirt Direct Tension Indicators. We would like to welcome our guest today, Rob Westover from Applied Bolting Technologies. Rob, welcome to our Texas workshop.
Thank you. Thanks for having me.
Yeah, and so great. You know, we had Chris on for our structural episode, but you know, this might be a different industry, I think. So,
Sure.
Can you tell us a little bit about Applied Bolting?
Yeah, so Applied Bolting, we make direct tension indicators. It's a single-use mechanical load cell that measures stud stress independently of torque. It's a little bit different than our structural line. You had Chris on earlier talking about structural DTIs. The flange DTI has its own bonded flat washer, which makes it pretty unique.
Right.
Some unique loads and unique designs.
That's awesome.
Okay, so you're manufacturing to a very specific compression load.
Correct.
What's the magic of how do you make that happen?
Sure, so it's based on the thickness of steel, the bump shape,
Okay.
and heat treatment to give us different loads that we need for the flange world independently of torque.
Right, and in order to get the right tension in each one of the bolted assembly on the flange.
Right, and KSI.
KSI.
So
Yeah.
the flange world doesn't necessarily talk about tension, they talk about stud stress or KSI.
That's right.
That makes good common sense. Okay, so what materials and what finishes do we see these washers?
Sure, so-
they're not washers.
They're not washers,
I
correct.
made that mistake. I've made that mistake several times, my friends. These are not washers.
Yeah.
These are load cells.
Yeah.
Correct.
We're going to call them load cells or indicators. Okay, go ahead, Rob.
Sure, so again, we make it out of carbon steel. For coatings, right now we're making it out of black oxide. Now the reason for that is that we're actually laser marking each one of these parts, and we'll kind of get into that later why we do that. Now, we can also do PTFE. Basically, any coating that you want, we can provide.
Right.
Okay, so there's a lot of specialty coatings being used in the flange industry or in the petrochemical industry. I'm going to get asked this question, so I'm going to ask you right now, and because in petrochem, there's a lot of stainless steel and super alloys being
Sure.
used. Have you had any experience with that, or can you make these parts in that?
So we haven't had experience with the stainless yet, but that doesn't mean we can't do it.
Okay.
We certainly, if we had a customer come to us that wants stainless steel, that's something we can provide.
Okay,
for sure.
take a little research to get there.
And it's not
absolutely.
as common in the flange world. A lot more carbon steel flanges is what you're going
Yeah,
to see.
and it's a big mixed bag. You know, a lot of stuff, a lot of companies will be a lot of carbon steel stuff, but then you'll get into the stainless as well.
Yep.
Initially, we can offer a PTFE part to kind of go with that stainless,
Yeah. Right.
but that's not going to be for everybody.
Yeah, you see that blue PTFE everywhere, right?
Right, exactly.
The other thing I was going to mention, Randy, was the fact that these aren't really held to a standard. Is that correct as far as, you know, ASTM per se?
Right, so our structural parts are made via F959, 606 testing. Now with the flange parts, we are making specific loads still kind of to that quality criteria, but different. You know, we're not doing F959 loads.
Right.
We're actually doing something very different for the flange loads.
You're making it to what the flange load, compression load of the flange needs to be.
Correct,
Yeah.
yeah.
Okay, I got that. So that explains then the direct tension indicator. Let's now talk about flange assemblies.
Sure.
So how are flanges assembled historically?
So traditionally, you're gonna install a flange with torque. And you're gonna use what's called the legacy pass. The legacy pass is basically the crisscross or star pattern.
Yeah, I think about changing the tire on my car.
Correct.
Absolutely.
Correct.
Exactly.
Same concept. There's a bunch of other ways to do it,
Yeah.
Right.
but really you're using torque and you're actually doing that star pattern is the most common way to do it.
Yeah.
And we're tightening here, we're tightening here,
Correct.
we're tightening here, and we're tightening here,
right.
and we have big old piece of pipe in the middle.
We do.
Yeah,
So
super
we're,
easy.
We're having to
Absolutely.
scramble around the big piece of pipe. It's not
Correct.
really quite like a car tire.
Correct. And it's multiple passes. So in the
Oh yeah.
flange world now, it's 30% of final torque, 60% of final torque,
Yeah.
100% of final torque, and then a ring pass on top of that with final torque.
Yeah.
So it takes a while.
So
Correct.
we're touching each bolt basically 3, 4, maybe even 5 times.
Correct.
Okay,
Yep.
now you've told us about something that is different.
Yes.
And a research paper that was done back in the 1990s.
Yes.
Tell us about that.
So it was an oil company back in the 90s. They sponsored a university to try to figure out how to tighten a flange in a single pass. Can this be done?
Okay.
And the concept behind that is compensating for elastic interaction.
Right.
And a simple example of that, we were talking about the car tire rims and everything.
Yeah.
If we were to use one load, start at noon and work your way around,
Right.
by the time you got back to that noon position, you may have some loose studs here and there. That's the way
Exactly.
elastic interaction works.
Exactly. It's acting on the other bolts you've already tightened
Correct.
up.
You tighten one, it has an effect against studs that are next to it and maybe studs across the flange.
Correct. So you end up with an uneven load
Correct.
on your assembly. So that's why we don't, but
Right.
this research paper told us something different.
Correct. So they figured out using ultrasonics or solid state load cells that they can actually tighten each stud individually to a different load. By the time they get back around that whole flange, it's at a nice even load.
Okay, you brought a little video on this that you're going to narrate for us.
Yes.
Let's watch that and let that explain itself to our audience on how the loads even themselves out.
All right, so we're gonna tighten the flange here. As we go through the flange, you'll notice that every time we tighten a stud, it has a direct effect on other studs in that flange. And this is what elastic interaction is. And you'll notice that every single DTI is being fired at a different load. And as we get through this flange, we get to the end on number 8, and everything is nice and even. And that's how you compensate for elastic interaction.
Rob, that video just makes absolute common sense. So this research was done back in the 1990s. Why is it the flange industry is not out there doing this today?
Yeah, so it comes down a lot to cost and their ability to actually do it out in the field. So when they did those tests, they were using ultrasonics, which
Okay.
is sort of hard to employ. You gotta, face
Right.
bolts and put them into a flange.
Certified technician for it.
Absolutely.
Yep.
Solid state load cells, expensive. Now when you use those, now they're stuck in the flange, so you can't get them back out. And so they just didn't grab onto that research because they really couldn't afford to do it.
So there really wasn't a viable way to do this out there in the field until now direct tension indicators gives us that.
Correct, absolutely.
So you brought a small flange with you.
Yep.
Let's set it up and prove it.
Yeah.
Sounds great.
Okay. Rob has set up his flange, but first of all, this has got to be really, really exciting for all of the industries out there that are using piping and flanges in their plants or in their assemblies, because this is absolutely revolutionary, Rob. So to begin with here, we have our safety glasses on.
Yep.
You have the gloves on because you're the one that's going to be handling everything.
Yep.
So tell us about your setup and how these are assembled.
Sure. So, as we described before, we're doing a single pass assembly here. We like to bring all these tools with us because we can talk about it, but proof is in the pudding. We actually like to show you and see how it's done.
I'm on board
So
with
we have our little mini flange here. It's a 2.5 inch 300. It's pretty small, but we travel with this a lot. We'll go to your office and do this demo. I have half of this kit already installed, so you get some multicolored studs there. The reason we put multicolored studs within this flange, which you wouldn't see normally out in the flange world.
Let's hope not.
Let's hope not.
Normally they stick to one finish.
Yeah, normally stick to one finish.
Right.
The friction factor is different
Yes.
with every different type of coating. We have yellow zinc, some PTFE, and some black bolt assemblies.
We don't know anything about that, do we, Randy?
Well, no, we know nothing about that. Yes, we do. Also, I want to note, Rob has not added any other frictional materials, such as a moly paste on these, that we do see some people do.
Correct. Yep.
So this is strictly just the coatings
Correct.
as they were. Okay?
Absolutely.
All
Yep.
right.
We also have our torque wrench over here that we're going to be using. Now, from a safety standpoint, it does have a pinch point. Be careful of that when you're using it out in the flange. This particular tool we've never calibrated, so calibration of tools very popular in the flange world,
Yeah.
but we actually don't need to do that with our single pass kits because the kit itself is what is calibrated.
You're really not talking about torque,
Yeah.
are you?
Correct. We're not talking about torque. We're
Okay.
just talking about KSI or stud stress. That is what we're talking about.
All right. Okay, so Rob, explain then how are the DTIs assembled? What's the total assembly? here?
Sure. So anyway, we're going to put our gasket in first.
Okay.
The reason we have this half apart is we got called out in the past. Did you weld it? No, we did not. this is a live demo.
Somebody
Hey,
thought you
I just
cheated.
witnessed. There's two of us here, so it did happen.
So we put our gasket in. Now our kits, from a size standpoint, are designed from 3-inch to 20-inch on class 300 and 600
Okay.
class flanges.
Okay.
And that utilizes specifically a spiral round gasket with an inner and outer ring.
Right.
Sure.
Cam profile gaskets also work as well.
Okay. So your compression loads on your kits are designed for those size flanges.
Correct.
Okay. Got
That
it.
size flange, 300 and 600 as far as the class,
All right.
and that specific gasket that goes
Okay.
in there.
All right. Sure.
That's where we started.
All right.
So I have half my kit already installed just to make our life a little easier here.
Sure.
And I'm going to install the other 1 through 4. On each of these DTIs, there's a number.
Okay.
There's also the size flange and the class of flange is supposed to go on. And it's really easy to install, really easy to see.
Yeah.
So let's start installing it.
And
Yeah,
they're
it's good.
boxed. They're boxed accordingly, right?
Yeah,
Correct.
they're boxed beautifully. So, this being a 2.5, 300, that's exactly what you need. You need 8, because that's
Correct.
the normal bolting pattern for that size. And they are numbered perfectly. It actually has 1 of 8, 2 of 8, 3, and so it just keeps going in sequential order.
Yeah, we would say that when you go to install a flange, you actually want to buy the gasket and buy the kit that all goes together. Makes it easy.
That makes sense.
Makes sense,
Yes.
So all I'm doing as the installer, and I am just adding the other 3 in order. Now, this kit can be clocked any way you want. You can do 1 through 8 starting anywhere you want, but you just got to count and tighten in order 1 through 8.
Okay.
Yeah, and I noticed here you've got the numbers on the flange itself. Just kind of help us out a little
Yeah,
bit.
it helps
so-
us out here. The demo makes the demo a little bit faster.
Sure.
Okay, Rob. So you have pre-installed all of the studs.
Yep.
Just hand tight.
Correct?
Okay. Where do we go from here?
Okay, so as you said, everything is installed, 1 through 8 in this case. We made sure that we had the right kit for the right flange.
Right.
So we're all good there. And there's a couple tips you need to understand because this is very different than what you've done before maybe with Legacy.
Okay.
So our wrench over here, we're not setting it to any kind of specified torque. It isn't a torque independent system, so we don't care about that.
Don't care about friction. This blows my mind. Okay, go
Yeah,
ahead.
so we don't care about that. We're going to be tightening from the non-DTI side.
Yeah.
So we
Okay.
installed our DTIs over here on this side of the flange. We'll be tightening from over here. I have my trusty backer wrench. We don't want the nut to spin.
Yeah.
So I got my backer wrench there. We do actually make these at Applied Bolting
It's a
as well.
nifty little
Yeah,
thing.
it's
Yeah,
got
it's pretty cool.
Yeah, pretty
I like
slick.
All right.
And now what the installer wants to do is tighten this first assembly until they see orange media come out of all bump locations. Now, that's
Okay.
important because this is a 4-bump DTI. You should see orange media come from 4 locations. When you see that,
Okay.
you're done. You go to the next stud.
What does it mean if I don't see it?
If you don't see it, that means you have not tightened the stud enough yet.
Don't call you up and tell you that your DTI didn't do.
Correct.
Okay.
Correct.
It just means keep tightening until
Keep
it
going.
happens.
Right.
Yep.
And one of the
Okay.
biggest tips is paying attention. So in the torque world, the wrench would do the work for you.
Right.
In this particular circumstance, all you gotta do is make sure you pay attention. The wrench isn't gonna do the work for you. You gotta look and move on from there.
When
Exactly.
the orange goo squirts out, you're done.
Absolutely.
Okay.
And
all right.
one at a time. So that's
One at
what's
a time, in
awesome.
order.
In
All right,
order.
Here we go.
Oh, this is
All right.
so different. You're just looking for orange goo.
Yep.
And
And
there
there
we
it
go.
is.
Cool.
It fired out.
I see it right over the top of the flange.
Yeah, me too. And be at 5 points, just like we saw on the structural side too.
4 points.
4 points. I'm sorry. Thank you for correcting me, of course.
Get it right there. Aaron.
Yeah, I know it.
Okay. I mean, that's it.
That is it. And
No
I-
torque concerns.
Right.
Yeah.
Just. Okay, that's too easy.
It's very easy. Yes, it's very easy.
Okay, so we'll go ahead and let you then do this for all 8 of
Yes.
the studs, and then we're going to do a hydro test on this.
We're gonna do a hydro test
We're
on
going
it.
to
Yep.
prove this out.
And prove it out. Right.
All right, go ahead and tighten up the rest of them.
All right, here we go.
All right, cool.
Okay, Rob, you have all 8 of them bolted up, and they all squirted really nice. Obvious, great visual, and it took no time for you to do that compared to traditional flange
Sure.
bolting. And you got some real-world story on that.
Yeah. So it was about a minute a bolt or so that we spent
Yeah.
on this. We had a customer that was using hydraulics and torque in the field. This happened to be a 12-inch 600 flange, so obviously bigger than this we got here.
Sure.
It took them about an hour and a half with a certified hydraulic tool to tighten that particular flange.
Two-man team.
Two-man team.
Yep.
All right.
When they got our product in the field, they started using the hydraulics, going in a circle, and then they asked, well, do we have to use a certified tool? And I said, no, you can use any tool you want. They immediately jumped into their truck and grabbed a faster tool, and it took them a minute a bolt to do that flange. So 20 minutes instead of an hour and a half.
Wow.
That is significant time savings on how long is that piping system down?
Sure.
As well as the cost of the man hours.
Absolutely.
Exactly right.
Wow.
Exactly right. Well, I think the only thing we need to do now is maybe prove this thing, so we got to
Right.
hydro test it.
Sounds
Go to
good.
hydro
Let's do it.
test. Let's pump it full of water.
That's right.
All right. Rob, you've loaded it up with water. We're at, I believe it's 1,500 PSI, which exceeds the test criteria
Does.
for this particular flange. And we have, I see, no leakage.
No leakage.
Okay, so that really proves out we have the seal is evenly pressured,
Yep.
so even compression pressure all the way around,
Yep.
doing exactly what we wanted it to do
Absolutely.
with a single pass.
With a single pass.
Okay, that's revolutionary, my friends.
It really is. So, what about situations where we might maybe have a rusted flange or something? You know, we talk about hot bolting a lot in flange assembly. So, how does that work? Do you guys have products on that?
We do. So we actually have what's called SSR DTI, so that stands for single stud replacement.
Yeah.
And the reason they use that is, say I wanted to service this flange here, and it's all rusty, it's pitted, it looks gross, and I know that my downtime is just a certain amount of time to have that machine down.
Right.
And so hot bolting, the concept is you can break one stud at a time off of this flange while it's in service. They lower the PSI down.
Over the pressure, okay.
But technically, it's still in service when they're doing hot bolting. That's the whole idea around hot bolting.
Okay.
Use our SSR to one at a time
All right.
replace the old junky stud with a brand new stud.
So I can do that still in that single pass system.
Yes, and you can actually, with hot bolting, you can do it in any kind of direction you want, which is kind of slick.
Really?
So yeah, so it's not
Okay.
just single pass. It's the concept is that the flanges has equal load when you got to it. So if it's in service
right.
and it's not leaking, it should be equal. So if you replace one at a time, however you want,
It's still staying
it's
equal.
still staying equal, and that's the point of the SSR. You're bringing it back to that known load.
Yeah, exactly.
Okay.
And it's actually got the KSI rating on
It does.
on
Yeah,
there,
yeah,
so that's
absolutely.
pretty cool.
Yep.
You etch that in.
We do. We laser etch everything into all the parts. So with single pass, you'll have 1 through 8 lasered there, like we've described.
Right.
The flange is supposed to go on, etc. With SSR, it'll say SSR etched on that particular part.
Okay.
If you call out 50 KSI, that's what I think or I know my flange is sitting at. We'll put 50 KSI on there.
Okay. Very good.
Great.
All right.
And then the other product you guys have is the target stress.
The target stress, and that works a bit differently than the current stuff we've seen. Target stress really is just to verify your current torque procedure actually works. So instead of driving it till you see indication, you do your typical torque procedure that you have, and then that DTI will, number one, tell you if your torque worked, and then number two, let someone know that you've been there and torqued that flange.
So that really is for someone that wants to just continue using torque.
Correct.
They've got their torque specs out there. They want to continue using torque, but introduce the direct tension indicator into the system now.
Very easy to do. They don't have to change anything in their spec to do that. Absolutely.
Okay. And it gives them verification.
It does.
Okay. Very good. Excellent products. I like the fact that this is not leaking at all, even compression. All right. Very good. Good proof. Thank you.
You're welcome.
In conclusion, direct tension indicators are mechanical load cells.
Yeah. Non-traditional system that we're using here, and why is that different?
Sure, so we're using that load cell to tighten a flange in one pass, one single pass. It's 75% faster than your traditional torquing legacy pass.
Which is a cost savings.
Absolutely, huge cost savings because you're less time at that flange. And really in the field, you know, the quicker you can get that flange back together, the faster that machine's up and running.
That's right. And then also an improvement in safety.
Definitely. So again, that one time around, reduces pinch points. You're only touching each stud one time instead of maybe 80 to 100 times with your traditional legacy pass.
Exactly. And then easy bolt up.
Very easy bolt up.
Not neglect frictional forces because,
We're not dealing with friction. Yes.
yeah, exactly.
So the bottom line is, these give you a verifiable, even clamp load every time. Bolt-up flanges with a single pass utilizing DuraSquirt direct tension indicators. Revolutionary and worth knowing.
Thanks to Rob Westover from Applied Bolting Technologies for coming out today to show us all about this system.
See y'all.